this is, and all of them are always laid out this way no matter what machine you order. It's going to be the contactor, which is basically a big on and off switch. When you turn the machine on, that's the click you're hearing. Then this is the AC to DC power supply. Most electricians, you'll hear just people call it a power supply. And then this is the level meter box over here. So this is what controls the level and fill meter on the boiler. So they're always laid out left to right in the same way no matter what machine. Thank you. So as soon as you have the machine plugged in, basically because this gets split, it doesn't allow power through to the contactor yet. But this middle component, the AC to DC power supply, that thing has power as soon as the machine's plugged in, not even turned on. So that thing will turn on as soon as you got plugged in. If you look close and you can bend down just enough, you can see there's a little green light that kind of illuminates underneath it. Depending on the machine, you can't even see it. But it's there. So then from that, out of the back side of that is it's putting out 24 volt DC and various amperage depending on 2-group and 4-group machine. So from that, basically, goes through the power button right here. Feeds right to this. So from here, when you depress this button, that actually is what allows 24 volts through to other components to turn on. So this AC to DC contactor, if you look on the back side, has a smaller red and black wire, and that's what you'll hear that click noise when you turn this on. Is this electromagnet that pops that up, and then now it's just a switch. It's allowing the higher voltage through that into the other components on the machine. So it goes from the back side of this 220 goes one line to the solid state relay right there, the little black box, and the other line goes to the heating element, and then 2 others go to the level meter box. So basically, when this is turned off, you can't power up the heating element, you can't fill the boiler. So apparently we've done 2 switches, one to allow boiler fill, one to it's grandfathered in at this point. Those are changes hopefully in the future will happen. But so basically the only components that run on high voltage at 220 are the AC to DC converter, takes in 220, converts it to 24 volt. The level meter box runs on 220. It uses a really small amperage, but it still uses 220. And then the heating element and solid state relay kind of work together. That uses 220. Everything else on the entire machine runs on DC voltage. So, that makes sense so far. You guys have any questions on how any of that part that I've gone over with works? Doing okay? All right. So, to get more into depth then on the 24 volt system now. So out of the backside, there's some people, depending on if you're talking to someone who does computer design, they call it a ground, but really it's the DC negative and positive. Some people will call the negative a ground, just as fair warning if someone's referencing a DC ground, they're talking about the V negative. So there's V positive, there's the positive and the negative. So the negative line out of the back of this actually goes up through this high limit switch on the boiler, and then one end goes into that and then out and directly over to the contactor. So what that does is if that boiler gets too hot, it breaks that connection and turns off the contactor. So now you can't get power to the heating element or to the boiler film. So if the boiler, something goes wrong and the boiler's overheating, eventually that will turn that system off, basically.
Does it reset?
It's a bimetal auto reset, and it waits until it gets below, I think it has to be 10% below its set temp, so it has to cool somewhat significantly before it can turn back on. And then the positive, that was what I was telling you, flows through the on-off button. You'll see a black line going through to this. Most of the DC is kind of in these various components. It's red is positive, black is negative. There's exceptions when you start going to some of these components because we have to label them differently depending on Crucible 1, Crucible 2 to keep track of everything. But so then out of the backside of the DC converter that goes to there, another negative goes to the level meter box, and that's to basically there's an on-off switch that tells it fill, don't fill, fill, don't fill, and that's turning on and off the V negative that's coming out of the AC/DC converter, and it goes right from there over to this. So the other end, the positive, I think it's just hooked up through a wiring harness eventually to the V positive, so that's just always hooked up, and then it turns on and off to the V negative, and that right there is what's controlling this on and off. And if you look underneath, you'll see it's 2 purple lines, and those are the V negative that turn on and off this boiler fill right here. And then the other components, as far as the negative and positive 24 volt, go through the power switch to the computer. So when you turn on this, it allows 24 volts to the contactor, which allows 220 through, and also turns on the computer. So when the machine's, until the button is pressed, this computer doesn't get power either. So from here, basically this is kind of the breakout box. So this is what has a small computer in here that takes information from the Nexus tablet and converts digital information from an Android operating system into analog outputs. So basically all this is doing is taking instruction from the via the USB cord from there to here and saying, okay, I'm seeing this many counts here. It's, you know, just looking for analog. I'm seeing power, I'm not seeing power when the thing is flipping around, and it just counts. Sends that there, that converts it to ounces. Same with this. It just, when that says, okay, I need hot water, this just turns on 24 volts to this. You need steam, turns on 24 volts to this. So this is, you know, as much as this computer, it's pretty much just a breakout box. This is physically where the power gets distributed to all of these components to just turn on and off. So that being said, if you need to check power on these things, for example, if I was to, turn on the steam solenoid here, is that thing up and running? You want to go to the switchboard page for me real quick? Okay, so let's go to Crucible 1 and turn on the steam button. So you can see I unhooked it, so it's not turning the solenoid on. And this is a quick way to see, okay, if I'm not getting steam, okay, is it this component or is there something wrong in the computer that's not sending a signal? So you can check right here, get out your voltmeter, make sure you're on DC voltage, and check right here between these two components. So you can go right there. Okay, I'm getting 23.7 volts. It's pretty appropriate, so that's working. You can go ahead and turn that off. Take some switchboard. Actually, I mean, we can leave it on for a second and we can check some other stuff. So this, I think it's 5 volt power. I think it uses 3 volts actually is the signal it sends. All the thermistors use 3 volts. And then the actuators that open this up here, those use 24 volts. Now if you're ever servicing Crucible, taking on and off, anything like that, where you could be, you know, doing anything where the thermistors are involved, that's why we say turn off the machine. Because it's just what I explained. The thermistor uses 3 volts of power with like maybe a half an amp. So you're looking at, let's say, 1.5 watts of power total. Now the actuator in here uses 24 volts and 1 full amp. So that's like 50 amps or 50 watts of power. So you're looking at like, you know, almost 40 times more power, one component right next to another. So if those wires accidentally cross and you didn't turn off the machine, all it has to do is seek that V negative that has 24 volts, and you end up frying the op amp in here that's attached to the thermistor. So that's why anytime you're working on the machine, as far as this kind of stuff, changing components at all, turn the power off to the machine, because it's real easy to, you know, it's a little op amp that's attached to the thermistor that's like a 50-cent component that's soldered on there, but you blow it and you ruin a, you know, $200 computer for just not remembering to turn off the machine. And then that's the other reason why anytime after any service, when you turn the machine back on, go right to switchboard and look. Like you can see right here, if I had 2 crucibles hooked up, I'd know something was definitely wrong with crucible 2 because I got a negative reading. So it's worth always, anytime you do any service, first thing, go right to switchboard, check to make sure all your temperatures are correct, because those are the more susceptible components, because those are using the lowest voltage on the machine basically. So those are always going to be your weakest components for blowing a computer. So as long as everything looks appropriate, then you can go through and start running your other tests. If you see something that's wrong, turn it back off, double check that your connections are on there appropriately. Whether the temperature looks super high, then the wires could be touching and you're getting a short, so it's not getting any resistance and it thinks it's really high. Or, you know, one's not connected or touching something else, which would be the worst case scenario, and it's still getting a wrong reading. So you should be able to tell, okay, is that a reasonable reading for the situation, both boiler and the crucibles. Because the boiler one's hooked up down here. If anything comes loose or whatever there, It's a little easier to see, of course. There's only one connection here versus a couple up here. But, so for power, that's, I'd say, the biggest thing to remember when working on the machine. Turn it off for that reason. Now that being said, if something is broken, you need to check power before you start removing components. I'd say the next thing that is more common as far as internal on machines is machines not heating or overheating, something like that. Something that you can kind of trace back to. It's got to be something with the heating element. So first thing you're going to want to check is, of course, let's say my boiler is not heating. So the first thing I'll do, go to AC, because the heating element, it runs on 220 AC. You should be able to check between the two leads here, okay? Oh, well, right now it's just maintaining, so I'm not heating. But you want, oh yeah, I was gonna say, can you hit the heating element button? So there, we just turned the heating element. There you go, I'm getting 235. And you know, you can kind of make sure you're getting it between all three. And that's just a good way to check, okay, I'm getting the power. If it's still not heating up, then there's something wrong with the heating element itself. If I'm getting the power there, then you need to replace the heating element, either the coil inside of it, like one of the electrical lines is faulty and it's broken or something like that. But normally, more often than not, if you run a boiler dry and burn up a heating element, if you guys are working with